Alright, this is kind of an extension of lesson 2, but I'm going to call it lesson 3. So your calendar will be a little bit off just based on the numbering system there with the lessons. So with this one, it's going to be a little bit complicated, so I do want to forewarn you kind of that. And so I'm not expecting you necessarily to understand it completely based on these videos, but it is something that you can get some examples down, and some of you might click, with it really quickly, and some of you will take some time to do this in class. But really what we're doing here is we're going to write repeating decimals as fractions. To do that, so for instance, you kind of want to look at the pattern that you have of how many places are repeating. For this particular one, we have just one place value is repeating. It's just the tenths place, and it's just a 6. And it keeps repeating on and on and on. If you have just one place, what we want to do is multiply it by 10. So it's just kind of the standard. If it's only one place, it's 1. Because what I want to do is move this decimal over just 1. Okay? So what happens here is if I multiply both sides, remember what I do to one side I have to do to the other. So I multiply both sides by 10. I end up with 6.6 repeating, which equals 6.666, so on and so forth. So what I'm going to do is I'm going to go back to that first step, and I'm going to call that, so that 0.6 repeating, we're going to call that n. Okay, so I'm just going to set this to an arbitrary variable. It doesn't really matter what you label it. Typically I'll label it a capital N. So I'm going to call that, that 0.6 repeating is n. Okay? So actually let me go back a second. Sorry, I know I'm going to make you erase some of your stuff here. So now if I focus on this and I multiply both sides by 10, what happens over here is that multiplying it by 10 moves that decimal. So I now have 6.666, so on and so forth. And on the other side, we have 10 times n. What I want to do is I want to get rid of this series of decimals. So I want to be left with just my whole number. Well, this whole series of decimals, I labeled as n. So if I subtract from both sides, 0.666, so on and so forth. So I subtract away this piece, that long decimal. Well, on the other side, that's really like subtracting just n. So I end up with 6 is equal to 9n. When I divide both sides by 9, I get that n is equal to 6/9, which is 2/3. So 0.6 repeating is actually equal to 2/3. So let me go back and kind of re-explain what happened here, because I know this gets confusing and I lose students here every year, every time I've taught this. So I understand. We're going to do some more examples and we're going to really get this down. So first off, what I did was I took that repeating variable and I set it equal to just a variable. Or took that repeating decimal, and set it equal to a variable, n. So that n is equal to 0.66666, so on and so forth. Down here, I multiply both sides of this equation by 10. So remember, when you multiply it, as many zeros as you multiply it by, it moves this way, that number. So when I multiply it by 10, that made it 6.66666, so on and so forth. And over here, multiply n by 10, and you get 10n. Well, what I wanted to do was get rid of this decimal, because I can't do anything if I have that huge, long repeating decimal. So if I subtract it away, that's going to leave me with just 6. Okay? Well, if I subtract it away over here, I have to subtract it away over here. Well, remember, on this side, it was equal to 0.66666, and over here, it was equal to n. So if on this side, I'm subtracting away 0.66666, over here, I'm simply subtracting n. It represents the same thing, I just wrote it two different ways. Over here it was 0.66666, over here it was n. If I subtract those away, I end up with 6, and then 10n minus n is 9n. Divide both sides by 9, and I get 6/9 or 2/3. Remember that n is my repeating decimal. So if I can find out what n is equal to, I actually know what my repeating decimal is equal to. So 0.6 repeating is actually 2/3. So let's try another example of that. Okay, so we'll move on to example 2. And again, this isn't something I'm expecting you to get right away, but I do want you to have some idea of, kind of what's happening here. So let me just get rid of all of this and we'll just rewrite. Alright, so we're just going to do one more. I'm going to do one more example with double digits. It works the same way though. So if I have 0.717171, so on and so forth, that would be like if I said 0.71 with a bar on top, and that's what it is. Okay? Well, that first thing, that repeating decimal, that's what I set equal to n. Okay? So right off the bat, we just set it equal to a variable. Now, because I have 2 decimals repeating this time, instead of 10, I'm going to multiply it by 100. Because what I want to do is I want to get one each of those in front of the decimal. So instead of multiplying by 10, I'm going to multiply by 100. So I multiply by 100, I end up with 71.7171, so on and so forth, equals 100n. Because I moved it 2 decimal places. Okay? Now again, I want to get rid of this big long decimal. Well, on this side, that's equal to 0.7171, so on and so forth. So I subtract those away. On this side, that was equal to n. So on this side, I'm left with 71. On this side, I'm left with 99n. Divide by 99. N is equal to 71 over 99, which is that 0.71 repeating. And so sometimes you won't be able to reduce, sometimes you will. Kind of depends on the problem. Okay, so it's really that same process. And again, I want to keep clarifying that I'm not expecting this to be, click right away. This is one of those concepts that kind of takes a little bit to sink in and to kind of try it on your own a couple of times, which we will do in class, so don't panic if that doesn't make sense right away. Okay? All right. So that's all we're going to do here. I just wanted to kind of do a couple of those examples on this particular concept, which is really why I'll probably call this, 2A or something like that. I don't even know if I'll change the lesson to 3. It'll just be 2A as kind of a supplement to what we did with lesson 2.